So, what are some of the useful graphic devices? The list of devices it found in devices. There are also devices created by users on CRAN. So, PDF. It is useful for line type graphics, vector format. It resizes really well. It is and it is usually portable. So PostScript is like older format, also vector format, and it resizes well, particularly well, but usually portable. But it can be used to create encapsulated PostScript files. Windows systems often doesn't have a PostScript viewer. Now Xfig. So good of you use use Unix and want to edit a plot by hand. PNG is the bitmap format. It's good for line drawings or images with solid colors. Uses lossless compression, like the old GAF format. Most web browsers can read this format natively. It is good for plotting many points. It does not resize well. So JPEG, it is good for photographs or natural scenes. Uses lossy compression. It is good for plotting many points. Does not resize well. Can be read by almost any computer and any web browser. It is not great for line drawings. And again, bitmap. It is needed to create a bitmap files, PNG or JPEG in certain situations. Uses GoScript. It is also can be used to create a variety of other bitmapped formats that are not mentioned in this slide. So BMP is again, it is the native Windows bitmap format. So we have like bitmap, PNG, JPEG, and a native bitmap format called BMP. So how do you copy plots? So like there are two basic approaches to plotting. First is to launch a graphics device, make a plot. You can annotate if needed, and then close the graphics device. Or there is one more way in which you can do it. So make a plot on a screen device, it's a default one, and annotate if needed, and you can copy the plot to another device if necessary. It's not an exact process, but I'm mentioning like these are some of the ways in which you can do it. So copying a plot to another device can be useful, because some plots, they require a lot of code, and it can be a pain to type all that in again for a different device. So device.copy, actually it's div.copy. I'll mention it as device.copy here. So device.copy, so it copies a plot from one device to another. So device.copy to PDF, so it copies a plot to a portable document format, that is a PDF file. So I using dev.copy, dev.copy.pdf, dev.list. So it shows the list of open graphics devices. And device.next, it switch controls to the next graphics device on the device list. Dev.set, it set controls to a specific graphics device. Next will allocate to the next graphics device. Set will allocate to a specific graphics device. And dev.off is it will close the current graphics device in control. So one simple thing to note here is that copying a plot is not an exact operation, but so why do I say this? You need to create presentations in multiple devices which will be used by the sales team or the marketing team or any other team. So when copying plot from one device to another, you need to know the specifics of how the graph changes according to devices. So now we'll see about lattice functions. So what are lattice functions is that it's an XY plot. This is the main function for creating scatter plots. So BW plot. It's called a box and whiskers plot. You can search in Google. You'll get the better idea of how the data is being formatted into box and whisker plots. Like histograms are your normal bar charts which are useful for creating better representation of data. So strip plot, it like a box plot, but with actual points. So dot plot is nothing plot dots on violin strings. So SPLOM is nothing but scatter plot matrix. So it likes pairs in a base graphic system, but it's a scatter plot matrix. So level plot, contour plot for plotting image data. So lattice functions, generally take a formula for their first argument, usually of the form y to x f star g. So on the left of the tilde symbol is the y variable. On the right is the x variable. After the are the conditioning variables. They are optional, and the star where it defines the interaction between f and g. So the second argument, it is the data frame or list from which the formula, which the variables in the formula should be obtained. So if no data frame or list is passed, then the parent frame is passed. So if no other arguments are passed, there are defaults that can be used. So hence these lattice functions also play a vital role in creating plots. Lattice behavior. So how do these lattice functions behave? So lattice functions behave differently from base graphics functions in one critical way. So base graphics functions plot data directly to the graphics device. But lattice graphics functions, they return an object of called class called trellis. So the print methods for lattice functions actually do the work of plotting the data on the graphics device. But lattice functions, they return plot objects that can be in principle it can be stored, but it's normally it is usually better you know to save the code plus data. That is always going to be useful. But here, instead of code plus data, you'll get plot objects also, which is also recommended. It's not a big issue. And on the command line, trellis objects are auto printed so that it appears the function is plotting the data. So what are some of the lattice plot panel functions? So lattice functions have a panel function which controls what happens inside each panel of the entire plot. So let's assume, like we have a x where random normal distribution of 100, and y is of it takes x plus random normal 100 comma standard deviation of 0.5. So we're basically combining two random normal variables of 100 comma 100, and you're just adding it. And f is a function of gl of 2 comma 50 labels. You're grouping them group 1 and group 2. Now you're just forming a xy plot from lattice panel functions. Xy plot of y to x. The condition is f being the factor here. So it plots y versus x conditioned on f. So here it is normally y conditioned on y to x conditioned on f. So this will be a plot. You can try this in this, and now the our programming is not in this device, it is not supporting plotting, and hence I'm not able to give a example here, but you can always try this and it will give a pretty good result of the xy plot. So again, the same function, what it basically is, the xy plot of y to x conditioned on f, panel equal to function of x comma y, panel dot xy plot of x. These are the internal functions that gets called when xy plot is declared. So panel dot ab line absolute line h equal to median of y, line type equal to 2. So it basically plots y versus x conditioned on f with horizontal dashed line drawn at the median of y for each panel. So adding a regression line, so xy plot of y to x conditioned on f, panel equal to function of x comma y, and panel dot xy plot of x comma y, panel dot lm line of x comma y comma col equal to 2, color is equal to 2, and it fits and plots a simple linear regression line to each panel of the plot. So with this, we conclude the the initial part of the plotting. In even we'll see a lot more on plotting, which will be very useful for constructing the plots useful for data representation.